discussed about atmospheric pressure and its measurement. So what I have told you is atmospheric pressure changes depending upon the height of the atmosphere. Atmospheric pressure is at high altitudes, the atmospheric pressure at high altitude becomes less. In the lower altitude, the atmospheric pressure is more. So using the same phenomenon, today's topic is measurement of atmospheric pressure. So there are different devices to measure the pressure, like for body pressure, the blood pressure, there is a different device. But to measure the atmospheric pressure, there are three devices. It's actually barometer, but there are three different types of barometer. Okay. First of all, we'll discuss about simple barometer. That will be today's topic. Another type of barometer is Fortin's barometer, and another is aneroid barometer. So for today, we'll discuss about the simplest barometer, that is simple barometer, and how does it measures change in the atmospheric pressure and so on. That also we'll discuss today. Now, as I've told you, a barometer is an instrument which is used to measure the atmospheric pressure. Okay, only the atmospheric pressure. So, simple barometer was the first which was discovered or made to actually measure the pressure of the atmosphere. So now simple barometer was designed in 1643 by a scientist named as Torricelli. Okay, he designed a simple barometer using a liquid inside which is known as barometric liquid. The liquid inside the barometer is mercury. And I'll tell you the benefits of using mercury and not other type of liquid also. Now, for the construction of barometer, what first he did was he took a test tube, okay, a test tube of hard tube glass or hard glass tube, which is approximately 1 meter in length. He took that and he filled that with mercury liquid, or liquid mercury. So first of all, he filled that with liquid mercury, 1 meter long hard glass tube, and he shaked it properly so that no air bubbles, no any other particles, no liquid, nothing is there inside. So it is completely filled with mercury. In the second step, what he did was he closed the test tube with thumb so tightly that nothing could enter the test tube. Only mercury shall be there inside, which is filled properly, that is 1 meter of length with mercury. In the second step, the test tube filled with mercury, he kept that on this kind of a drawer which is already filled with mercury. So there are two things in this device. First of all is a test tube filled with mercury. Second one is this, which is known as straw. This plate kind of a thing, straw, which is already filled with mercury, and a test tube filled with mercury. Secondly, what he did was he kept that test tube in this straw, vertically upside down, so that the liquid, the opening of the test tube is upside down inside this straw. Now this is also filled with mercury and the test tube is also filled with mercury. I hope it's clear to you. And now we're using this device. This is actually a simple barometer. Using this, we can measure the change in atmospheric pressure. Now, what happens over here is, this is open space. Air can or atmosphere can enter at this point and put a pressure liquid at this point. Okay, at this point also. So this level of the mercury in the draw is denoted as C. Okay. Now there is mercury inside the test tube also. So that height of the mercury is A, B. Okay, B is the end of the test tube. So this will be the end of the mercury. This is the starting of the mercury. That's inside the test tube. Now A and C are at the same level. When we make it upside down, this A and C will be at the same level. And the height AB is H. Now the next thing what we know is, in the last class also what I told you is, if there is a liquid at a certain level, at this level, at all this level, the pressure will be same. So if it's another level, the pressure also will be same. So using this thing over here, what we can see is the pressure at A and the pressure at C should be same. At first, the pressure is different because C is due to the atmospheric pressure. The atmosphere is putting pressure on this level C, whereas A is inside the test tube. Inside the test tube, the pressure is due to the weight of this mercury column. Okay, this mercury column is putting pressure in this part, that is A. So A and C initially will be at different pressure level. But after a while, the pressure is so adjusted that A and C will be at same level of atmospheric pressure. How is that adjusted? When this weight is putting pressure on this point of the liquid, so by increasing or decreasing the height of the mercury column over here, the pressure is adjusted. That is the phenomenon, and that is how we see the change in pressure. So initially, I tell you again, initially A and C are at different pressure. After a while, A and C will be at same pressure. So we have to wait for a while so that the pressure changes. Now, what happens when the atmospheric pressure change? Now, when the atmospheric pressure is more, so what happens? The pressure at C will also be more pressure at this point C. So at that point, this pressure will be felt in this mercury, and the mercury will move back to the this test tube column. That means the height of this will increase. So remember that whenever the pressure is more, whenever the atmospheric pressure is more, the mercury column, the height of the mercury will increase. Whenever the pressure is less, the height will decrease. That is how a simple barometer works. Okay? Use, to measure the atmospheric pressure, if it is more, level increases. So if the level is increased, we have to know that atmospheric pressure is more. If the pressure is this level is slightly less, then the atmospheric pressure is less. Now the next thing, things which you need to remember is this point over here is vacuum. This point is also known as Torricellian vacuum. Okay, this point is also known as Torricellian vacuum. This point, this H is the barometric height. Height of the mercury is the barometric height, which gives us the idea of if the pressure is increased or the pressure is decreased. If it is more, if it has risen from its initial level, then the pressure is more. If it has decreased from the initial level, then the pressure is less. Now, the barometric height is normal at temperature. At normal temperature and pressure, it's 76 centimeter. We have taken a test tube of 1 meter. The length of this test tube is 1 meter. But at the sea level or at normal pressure of the atmosphere, this will be 76 centimeter. 76 centimeter is equal to 760 millimeter, which I have already told you. 760 millimeter is actually the normal atmospheric pressure. Okay, 766 millimeter of mercury. So this is what it means. If we take a test tube of 1 meter length, then at the normal pressure, it rises up to 760 millimeter. This level is 760 millimeter. So this is 760 millimeter of mercury. This will be one of the units of atmospheric pressure. Suppose we change this mercury with different type of liquid, then it will no longer be 760. If you take water, it will be more than 760. If you take any other liquid, it will be more or less depending upon the density of that liquid. So for mercury, it is 760 millimeter of mercury. That will be the atmospheric pressure of, or the normal atmospheric pressure. Now suppose if you tilt this barometer, still the height remains 760 millimeter of the mercury. So it doesn't matter if you tilt this or if you make it at any angle, the height of the mercury level still remains the same. Okay, now another thing what you have to remember is a simple barometer is not a perfect barometer. It has got some fault in it. The fault in this barometer is over here this space is open to the atmosphere. So if this space is open to the atmosphere, any impurity from the atmosphere can enter it. And if impurity enters it, then this will be not a perfect barometer. It will be known as faulty barometer. And with the if some air molecules or vapor, if it enters over here, then also this will become a faulty barometer. Now, advantages of using mercury as a barometric liquid. Okay, mercury. Why do we use mercury instead of any other liquid? The first one is the density of the mercury is greater than that of any other liquid. Mercury is a very thick liquid, so it works perfectly for this length of a barometer. Now, suppose if you take any other liquid with a lower density, then the height of this mercury column or the height of the test tube should not be 1 meter, it should be more than that. Okay, so for this height or this length of the test tube, mercury is a perfect liquid. Now, the second advantage, the vapor pressure of mercury is negligible, so the vapors in the torsion vacuum does not affect the barometric height. Now, if this gets heated up, if it changes into vapor, then that will not affect the height of this one, because the vapor pressure of the mercury's vapor is very less or negligible. Now, another thing is mercury neither wets nor sticks to the glass. If you happen to see mercury in the lab, then if you keep it in your palm also, you should not keep it in your palm, but if you keep it in a table, then it will not stick to that surface. It will slide over it, but it will not stick. Similarly, if you keep inside a test tube, it will not stick to the walls of the test tube. It will simply slide over it without leaving any traces of mercury. That is the most important advantage of mercury. Another one is the mercury is shiny and opaque. Shiny and opaque means from outside the test tube also we can clearly see the mercury because it's very clear liquid. Like the color of the mercury is quite silvery, so you can easily see the level of the liquid changing. If you happen to keep water inside over here, then what happens? Sometimes the color of the test tube and the water is colorless. That is why you will not be able to make out the level of the water. So if we keep mercury, then we can easily make out the level of the mercury because of its opaque nature. And another one is mercury can be easily obtained in a pure state. So unlike any other liquid, mercury exists in its pure state. Now, using this, you also have an idea of disadvantages of using water, because the density of water is low, first one. So if you keep water over here, then the height of this test tube has to be more than 1 meter. The vapor pressure of water is high, that if the water changes into vapor, it will exert pressure, and the pressure will not actually be able to calculate the actual atmospheric pressure. And another thing is water sticks to the glass, water is colorless, so it will not be easily seen. Those are the disadvantages of using water. Now, demerits of a simple barometer. Now, this is a simple barometer. What are the demerits? From here, what you can easily see is this surface is open, so it will not give a perfect reading because any impurity enters over here, that will change the level. Okay. Another thing is there is no scale over here. Okay, the scale is not there, so that you can easily read the level of change over there. It is inconvenient to take it from one place to another. Suppose if you take from one place to another, it might slide and fall down. So this is not at all portable to take it from one place to another. So there are many disadvantages of this. So instead of a simple barometer, what we use in the lab is a 14 barometer. So for today's class, we'll keep our discussion up to simple barometer. In the next class, we will discuss about 14th barometer, how it is made. It's actually similar, but some improvements have been done in that 14th barometer. I hope till here it is very much clear to you all. We'll continue in the next class. Thank you.